On question number 8, all three of them are used to show similarity. For angle, like we did yesterday, we have to show two angles are congruent. For side, we have to show the sides are in proportion. And it's all three sides. For side, we need to know or show two sides are in proportion. And the angle between them are congruent. And so that's how we're going to approach number 9. I notice on this one that I've got side, angle, side here for the first one, but I don't know D to B. But the nice thing, it's a right triangle. So what I'm going to do is I'm going to use C squared equals A squared plus B squared. On the second triangle, my hypotenuse is 4. One of my legs is 2 radical 2. And I square that. And then I'm going to solve for B. I'll call it B. Okay, so 16. Now what happens when I square 2 square roots of 2? Well, what happens is 2 squared is 4. I'm going to write that down here. And the square root of 2 squared is 2. So in other words, 16 equals 8 plus B squared. Well, it's minus 8 from both sides. And we get 8 equals B squared. So I'll take the square root of both sides. The square root of 8 is the square root of 4 times the square root of 2, so it's 2 radical 2. Notice my legs of both triangles are in the same ratio. They're both isosceles, so they have to be in the same ratio. So are these two triangles similar? Yes. What's the reason? We did side, angle, side similarity. I guess you could have done side similarity if you would have used Pythagorean theorem to find EG. Then you would have had to go back and still would have had to find D to B. Well, I just think it's easier to do side, angle, side. But side would have worked on this one if you want to put the work in. On question number 10, if we add the same thing to all three of them, they won't be in the same ratio because ratio means divide. But what happens if we make x 0? If x is 0, then that would work. I don't know what I did there. I wanted just to make it a little bit thicker. So x is 0, then it works.